Imagine you're cleaning out a shared drive at work. You open a folder called Miscellaneous. Inside is another folder called Old Stuff. Inside that is a folder called Final. Inside that are three files: final.docx, final underscore final.docx, and final v2 real final.docx. No dates, no context, no idea who created them, no idea which one matters. You hover over each one. You open the first, you scroll to the bottom. It seems complete. You open the second. It looks different. You're not sure if the differences are intentional or accidental. You open the third and discover it ends mid-sentence. 15 minutes later, you've learned nothing useful. You close all three and send a message that says, "Hey, does anyone know which version of this we're actually using?" No one replies for 2 days. When they do, it's someone who left the company 8 months ago and just happened to still be in the group chat. If you've ever experienced that flavor of dread, I know the information is here somewhere, but I can't find it. Then congratulations. You've already felt the pain that databases were invented to solve. Today's episode is about databases, databases for humans. Nothing scary and nothing technical. No coding, no jargon, no computer science degree required. This episode is about how normal office workers already use databases every day. They just don't always know it. We're going to talk about why some systems work better than others and why understanding this one foundational idea will unlock your ability to automate almost anything. Here's the principle I want to leave you with today. If you want to automate, you must first understand how information is stored. That's the whole episode in one sentence. Everything else is elaboration. So let's go. What is a database really? When most people hear the word database, they picture something intimidating: servers humming in a locked room, programmers typing green text on black screens, something that belongs in IT, not in your Tuesday morning. But let's strip that word all the way down. A database is anything that stores information in a way that can be read later. That's it. That's the whole definition. By that definition, a notebook is a database. A filing cabinet is a database. A library is a database. A spreadsheet, a calendar, a sticky note on your monitor is a database. And the contact list in your phone is a database. Even the earth itself is a database. That's right. Geologists look at layers of rock the way we look at rows in a spreadsheet. Each layer is data. Each fossil is a record. The earth stores information about its own past. And if you know how to read it, you can reconstruct events that happened millions of years before anyone was around to write them down. Ancient civilizations understood this instinctively. The Sumerians stored records on clay tablets, invoices, land deals, census records, thousands of years ago. And here's the remarkable thing: those tablets are still readable today. The medium was durable. The encoding was consistent. The meaning survived. The medium changes. We went from clay to papyrus to paper to punch cards to hard drives to cloud servers, and one day, maybe something we haven't invented yet. But the idea never changes. Data is information encoded in a medium so that meaning can be recovered later. I want you to sit with that definition for a second because it reframes the whole conversation. The question isn't, is this a real database? The question is, can I or anyone else recover meaning from this later? If the answer is yes, reliably and quickly, good database. If the answer is, well, it depends who you ask, or it's complicated, or you'd have to dig around a bit, that's where the problems start. When we automate office work, our goal isn't to become programmers. Our goal is to intentionally encode information in a way that future us and future systems can understand. The final real final.docx problem isn't a technology problem. It's a failure of intentional encoding. Someone stored information, but they stored it in a way that makes meaning hard to recover. Why databases are the foundation of automation. Let me tell you something about automation that nobody mentions in the software demos, Automation doesn't fail because the tools are bad. Automation fails because the data is messy. I'll say that again because it's really important. Automation tools like Power Automate, Zapier, Make, Python scripts, AI assistants, all of it. These tools are genuinely impressive. They can move information between systems at incredible speed. They can run processes that would take a human hours in a matter of seconds. But they have a fundamental limitation. They do exactly what you tell them to do, nothing more. They have no intuition, no common sense, no ability to guess what you probably meant. They can't look at final v2 real final docx and figure out that it's the document from the Henderson project that needs to go to legal by Friday. They see text and structure. That's it. If your data is vague, automation reflects that vagueness back at you, faster at scale. Think of it like this. Imagine hiring an incredibly fast, incredibly literal assistant. You say, file all the invoices from this month. They say, how do I know which documents are invoices? You say, they're the ones that say invoice at the top. They say, 4 of them say invoice and 3 say bill and 2 say statement. Which counts? You say, all of them. They say, some of them don't have dates. What month is this month? And on it goes. A human assistant would figure most of this out. They'd use context. They'd ask one smart question. They'd make a reasonable judgment call. An automated system will either stop and ask for clarification or worse, charge ahead and make a mess with complete confidence. This is why I always tell people, before you ask, how do I automate this? Ask, is my data ready to be automated? The good news is that this is a learnable skill. It doesn't require a computer science degree. It requires a specific way of thinking about information. That's what the rest of this episode is about. 4 principles of useful data. Let's talk about 4 principles that apply regardless of whether you're using a notebook, a spreadsheet, or a system that costs your company $10,000 a month. Principle 1, if you want to find it later, you must store it. This sounds so obvious, it barely needs saying, and yet offices violate this rule constantly. Decisions made in meetings that were never written down, agreements that live in someone's memory and someone else's inbox, critical context that exists in a conversation from 2 years ago in a chat platform that the company has since switched away from. I once worked with a team that spent 3 weeks reconstructing a decision that had been made 18 months earlier. Not implementing the decision, reconstructing what the decision actually was. 3 weeks of emails, interviews, and searching through archived messages, all because no one wrote it down in a permanent findable place. The rule is simple. If information matters in the future, it deserves a home. Not a partial home, not a temporary home, a deliberate, findable home. No storage, no retrieval. And no retrieval means no automation. You can't automate a process built on institutional memory. Principle 2, organized data is worth more than raw data. A garbage dump technically stores a lot of material. There's food, metal, plastic, glass, fabric. You could recover any of it, but you'd spend enormous time and effort just figuring out where to look. And by the time you found what you needed, you might not be sure it was still usable. Unorganized data is the same thing. The goal of organization isn't tidiness for its own sake. The goal is to make meaning recoverable without needing to be an archaeologist. Good data should answer basic questions quickly. What is this thing? When was it created? Who owns it or created it? What status is it in? Where do I go if I have questions? If recovering any of those answers requires digging, guessing, or emailing the person who probably knows, your data hasn't done its job. There's a practical test I like to give. Imagine you go on vacation for 2 weeks and come back to find someone has added 50 new items to your shared system while you were gone. Can you scan through them and immediately understand what they are? If yes, good organization. If you find yourself thinking, what is this and why is it here? That's a sign the system needs work. Principle 3, data gains value through relationships. Here's the one that surprises most people. A single name sitting alone in a document somewhere is almost useless. John Smith. Okay, which one? What about him? But a name connected to a company, a contract with an expiration date, a set of emails, a set of meetings, a payment history, a record of issues. Now that name becomes the center of a web of meaning. You can answer real questions. You can see patterns. You can take action. This is what modern databases are actually for, not storing data, connecting data. When you look at a customer relationship system, a project management tool, or a well-built SharePoint site, you're looking at a system that has been designed to make relationships between pieces of information explicit and navigable. Even in a simple spreadsheet, you can build relationships. A column that says client connects your row to everything you know about that client. A column that says status connects your row to a category. A column that says owner connects your row to a person. None of this requires a fancy system. It requires intentionality. The question to ask when building any data structure is, what will this piece of information need to connect to? Principle 4, data is not the goal, meaning is. This is the one that brings it all together. No one wants data for data's sake. Data is a means to an end. The end is an answer to a question, a decision that gets made, a story that can be told, a process that runs without thinking about it. Humans interpret meaning, machines organize information, and automation is what happens in the space between those two things. The best data systems are structured enough for machines, consistent, clear, predictable, and meaningful enough for humans, intuitive, navigable, trustworthy. When those two things are both true, automation becomes almost obvious. You look at your data, you look at your process, and you think, of course this can be automated. The hard part is already done. When only one is true, structured but meaningless, or meaningful but messy, automation becomes a nightmare. Applying this to real office work. Let's bring this down to earth with some concrete examples. Office work is fundamentally about managing items. Every office has them: meetings, emails, contracts, invoices, employees, projects, requests, approvals, assets. Each type of item has a natural shape, a natural set of data that defines it, and a natural home where it belongs. Take a meeting. A meeting has a date and time, a duration, an organizer, a title or purpose, a location or link, a list of attendees, notes from what was discussed, action items that came out of it. That's why meetings belong in a calendar, or for the notes and actions in a dedicated meetings notes tool. You would never store a meeting record in your invoicing system. Different item, different shape, different home. Or take a contract. A contract has two parties, at least, a start date and an end date, a value, a status, whether it's a draft, signed, active, or expired, a type, a set of associated documents, an owner, a renewal date. That's a very different shape from a meeting, and it deserves a very different home. A contracts database, a document management system, or at minimum, a well-structured spreadsheet. The reason so many office systems get messy is that people force items into the wrong shaped containers. They try to track contracts in a calendar. They try to manage projects in an email inbox. They try to run approvals through a shared document. It's like trying to organize a library by putting all the books in chronological order of when you bought them. Technically, every book has a place, but good luck finding anything. Automation begins when you respect the natural shape of the information. When you understand what an item is, what data defines it, and where it belongs, you're ready to automate it. Folder trees, the old faithful. Let's talk about the first system everyone learns, the one that's been with us since the dawn of personal computing, the humble tree folder, or folder tree. Folders are intuitive. They mirror the physical filing cabinets that came before them. If you've ever worked in a physical office and dealt with actual paper, you already understand folders instinctively. They have real strengths. First, they're universally understood. No training required. You put a file somewhere logical, tell someone roughly where it is, and they can usually find it. Second, the folder path itself carries meaning. Consider a path like 2025, finance, and then Q2, and then invoices, and then approved. You're encoding 5 pieces of information about every file in that folder just by where you put it. Year, department, quarter, document type, status. That's metadata, even if it doesn't look like it. Third, they're reliable. Files go where you put them. They stay where you put them. There's no system to break, no database to corrupt, no settings to misconfigure. The problems emerge the moment reality gets complicated, and reality always gets complicated. What happens when something spans multiple years? A contract that starts in 2025 and ends in 2027. Does it live in the 2025 folder, the 2027 folder, both? If both, you've got 2 copies and no clear answer to which one is current. What happens when different people have different mental models of how things should be organized? One person sorts by year, another sorts by client, another sorts by project type. Folder trees force everyone to agree on one hierarchy. And in the real world, that agreement is hard to reach and harder to maintain. What happens when you need to find things by a category that isn't reflected in the structure? If your folders go client to project to year to document type, and someone needs to find all contracts across all clients that are expiring this quarter, the folder structure is no help. You're doing a manual search. The fundamental problem with folder trees is this: they force you to pick one true way to organize information. And most information has more than one legitimate way to be organized. The folder tree asks, where does this belong? And often the honest answer is, it depends on who's asking. Spreadsheets, the gateway database. Now let's talk about spreadsheets. And I want you to make a case that spreadsheets are actually one of the most powerful and underappreciated database tools ever invented. Not because they can replace enterprise systems, they can't, but because they force a way of thinking about data that is genuinely valuable. The mindset shift. In a folder tree, the question is, where does this live? In a spreadsheet, the question is, what are the properties of this thing? Let's take the contract example again. In a folder tree, a contract lives in exactly one place, but in a spreadsheet, a contract is a row, and all its properties are columns. You could have the columns of contract name, client, start date, end date, value, status, owner. And then one of the records of contracts, we have the contract name is services agreement. The client is Acme Corp. The start date is 1 Jan 2025. End date 31 December 2026. Value 45,000 pounds. Status active. Owner Sarah. Now I can filter by status to find all active contracts. I can sort by end date to see what's expiring soonest. I can filter by owner to see Sarah's portfolio. I can search by client to find everything related to Acme. The contract is no longer in one place. It's findable from any angle. This is a relational mindset. Even if you've never heard that term, you're modeling the properties of a thing, not just deciding where to put it. The real strengths of spreadsheets as databases. Every row is one item. Every column is one piece of metadata about that item. This structure is immediately sortable, filterable, and searchable. Spreadsheets are also excellent at relationships. You can have one sheet for clients, one sheet for projects, one for contacts, and use consistent names to connect them. Lookup functions can pull information from one sheet into another. It's not as elegant as a proper database, but it works. And crucially, spreadsheets are the format that most automation tools love. When you connect Power Automate or Zapier to your data, they want rows and columns. They want consistent fields. A well-structured spreadsheet is very nearly automation ready out of the box. Where spreadsheets struggle. Spreadsheets are not good at storing files. You don't want to cram PDFs and Word documents into cells. You want to point to them, a link, a reference, a file name, but the actual files belong somewhere else. They're not great with large teams editing at the same time. Version conflicts, overriding each other's work, and the eternal problem of which copy is the real copy all gets worse as the team grows, and they have no real enforcement mechanism. Nothing stops someone from typing Acme Corp in one row, Acme Corp with small letters in another row, and in the next, simply Acme. From a human perspective, those are the same client. From an automation perspective, they're three different things. Spreadsheets are vulnerable to inconsistency, but used thoughtfully, a spreadsheet is an extraordinary tool. Many of the best office automation setups I've started with had a well-structured spreadsheet. The hybrid approach, getting the best of both. Here's where things get interesting. You don't have to choose between folders and spreadsheets. In fact, the most practical office systems use both together. The approach works like this. Use a spreadsheet as your index. Use folders as your filing system. Your spreadsheet has one row per item, one row per contract, one row per project, one row per client. Each row has all the metadata, dates, status, owner, type, value, whatever matters. And one of those columns is a link to a folder that contains all the documents related to that row. Now you have the best of both worlds, the flexibility and searchability of a database combined with the familiar structure of a folder system. You find what you need in the spreadsheet, then navigate directly to the files. This is not coincidentally exactly what platforms like SharePoint document libraries are doing under the hood. When you create a document library in SharePoint and tag a file with metadata, you're assigning row style properties to a file system style object. You can filter and sort those files by metadata, just like spreadsheet columns. And you can also browse them in a folder view, just like a traditional structure. Why this matters for automation. Once your data looks like this, items in rows, properties in columns, files linked but not crammed in, automation becomes remarkably straightforward. Automation tools think in rows. They ask, for each row in this table that meets a condition, do something. If your structure is if your data is structured as rows with clear properties, you can almost always translate a manual process into an automated one. If your information is scattered across folders with inconsistent naming, buried in email chains, or split between someone's memory and a shared doc that no one updates, automation can't help you. Not really, not reliably. The spreadsheet plus folders approach is the bridge. It's not glamorous, it doesn't require a subscription, and it's where most successful office automation starts. The limits of spreadsheets and when to go further. Before we wrap up, I want to briefly acknowledge that spreadsheets aren't forever. There comes a point in most organizations or most projects where a spreadsheet starts to show its cracks. Too many people editing at once, formulas breaking, someone deleting a column they shouldn't have touched, the file ballooning to a size where it takes 30 seconds to open. When that happens, it's a sign that the data has outgrown its container. The next step is usually a dedicated database platform. You don't need to worry about the specific database platform today. The principles are the same regardless of which one you use: rows, columns, properties, relationships. What matters is that you recognize the pattern and know that moving to a more powerful system isn't starting from scratch. It's graduating to a bigger version of something you already understand. 5 practical questions to ask about any data you manage. Let's make this actionable. The next time you're setting up a system, organizing information, or preparing to automate something, run through these 5 questions. 1, what is the item? Everything starts here. Not what is the file or what is the folder. What is the thing you're tracking? A contract, a meeting, a client, a request? Name it clearly. 2, what data defines it? What properties does this item always have? What questions would you want to answer about it? Start there. Date, owner, status, type, value, whatever makes that item complete. 3, where should it live? Given what this item is, what kind of system makes sense? A calendar, a spreadsheet, a folder structure, a combination? Match the container to the shape of the item. 4, how will future me find it? Imagine you need this item in 6 months and have completely forgotten its name. What would you search for? What filter would you apply? Design the system to answer that search. 5, is this consistent enough for a machine? If you plan to automate anything related to this data, it needs to be consistent. Same field names, same date formats, same terminology for status values, one client, one spelling. This is usually the hardest thing to get right and the most important. Run these 5 questions on whatever you're building or fixing, and you'll find that the right structure usually makes itself obvious. So here's the big takeaway from today. You don't need to become technical to automate office work. You need to become intentional. There's a role in large technology companies called a data architect. Their job is to look at an organization's information and ask, how should this be structured? What belongs where? How do things connect? How do we make sure meaning is recoverable? It sounds like a technical job. In many ways, it is, but at its heart, it's an act of translation. It's taking the messy, overlapping, ever changing reality of an organization and finding a structure that can hold it reliably. You can do this, not at an enterprise scale, not right away, but in your corner of your office, in your team's shared drive, in the spreadsheet you manage, in the system you're building. Before you ask, how do I automate this? Ask, what is the item? What data defines it? Where should it live? How will future me find it? When you organize information well, automation becomes almost obvious. Not always easy, but obvious. The question, how do I automate this, has a clear path forward when the data is in good shape. The final, real final .docx problem doesn't get solved with better automation tools. It gets solved by someone deciding in advance that documents will be named by date, version, and project. That's data architecture. That's all it is. In, in future episodes, we're going to be going further. We're going to go into the other side, not just database, but interface. What I often like to think of when I think of a database is you can have anything holding data. Maybe it's a black box, and you need to be able to have ways to interact with that data. You need to be able to read the data, take measurements. You need to be able to write data into that system. You need to be able to look things up, and you need to be able to delete items from there. But in order to do these kinds of actions, we actually need an interface, which is what we will go over in the next episode. And until then, here's the thing I want to leave you with. Automation starts long before the button is pressed. It starts where data is born. Thanks for listening to Automate Office Work. If you found this useful, share it with someone who's still living in folder chaos. They need this more than they know. And until next time, happy automating.